Synthetic resin is a chemical substance artificially created to mimic the traits of its natural counterpart. Synthetic resins are non-crystalline or viscous liquids. Synthetic resins are industrially manufactured via the process of polymerization, which includes the introduction of chain-related polymers, allowing for extra stable, homogeneous resulting structures than is found in naturally going-on resins. Fiber-reinforced composites have resin as one of the two main ingredients, other being the reinforcement fabric. This lecture describes properties, advantages, and limitations related to various resins. This will allow better understanding to the manufacturer while choosing the resin for any application and product. Composites manufacturing industry, resins act as the matrix that binds reinforcing fibers together, transfers mechanical loads, and protects the fibers from the environment. Resins widely used in composites industry are listed in the next slide, followed by their detailed properties in subsequent slides. Present slide shows list of resins widely used for various applications in daily life. Merits and demerits of all these are discussed in preceding slides of this lecture. Polyester resin's main advantages are its low cost, ease of use, fast curing, and good water/chemical resistance, making it great for general fiberglass, boat building, and molds. This easy-to-handle resin is good for use in fast-curing hand layup, spray-up, filament winding, pultrusion and compression molding. Its limitations include brittleness, lower strength than epoxy, significant shrinkage, poor adhesion to some materials, and strong VOCs during curing, making it less ideal for high-performance or intricate applications needing superior bonding or flexibility. These find use in hand layup, resin transfer molding, RTM, pultrusion, and vacuum infusion. Vinyl ester resins offer excellent chemical and corrosion resistance, superior strength, toughness over polyesters, good water and heat resistance, property of flexibility, make them ideal for harsh industrial or marine use. These are pricier, can have short shelf lives, contain toxic styrene and less modified, and require precise curing, with less UV resistance. Surface finish of products is not of very high quality. Polyurethane, PU, resin offers great toughness, flexibility, abrasion resistance, and strong adhesion, making it versatile for coatings, adhesives, and casting. It combines rubbery elasticity with metallic strength. These are applied in pultrusion, RTM, reaction injection molding, also called RIM. PU resin has limited UV and heat resistance, and less formulated. Moisture sensitivity causes bubbles, potential toxicity, isocyanates, and fast cure times challenge beginners during handling. Its sensitivity to moisture and heat demands precise application. Hand layup, vacuum infusion, autoclave molding, filament winding, RTM, prepreg methods produce parts from this resin. Epoxy resin offers excellent advantages like superior adhesion, high strength, chemical and water resistance, and durability, making it great for coatings, adhesives, and composites. It has limitations including brittleness, UV sensitivity, causing yellowing of cured surfaces with time. It has long cure times, generating strong fumes during application. Special surface preparation procedures are essential while using this resin. Phenolic resins excel in heat, fire, and chemical resistance, offering excellent electrical insulation, durability, and machinability, making them great for high temperature and safety uses. However, these are often brittle, can be heavier, may have higher initial costs, and pose health concerns with unreacted phenol/formaldehyde, limiting aesthetic appeal, which is often solved with fillers. The best processes for producing parts with this material are open molding and resin transfer molding. Phenolic resins are prone to cracking under impact, often needing fillers for toughness. Phenolics produce dull finish. Unreacted phenol and formaldehyde are hazardous, requires careful handling to reduce emission control. Phenolic composites are heavier than some materials and have higher initial cost basic alternatives. These undergo significant shrinkage during curing. Alkyd resins offer great adhesion, flexibility, gloss, and durability, making them suitable for wood and metal, but they suffer from slow drying, strong odors due to VOCs, potential yellowing, and difficult cleanup, requiring thinners. Although these provide excellent value and performance, especially for industrial primers and decorative paints, but modern demands push for faster drying, eco-friendlier alternative. Air drying of these resins takes longer, requiring dryers in formulations. Can yellow over time, especially with UV exposure, though urethane-modified versions are better. Traditional alkyds have strong odors and high VOCs. These are not as robust as epoxies against strong chemicals. Ester bonds can break down in humid conditions. Acrylic resins offer great advantages like high clarity, weather resistance, versatility for use in dentistry, paints, and plastics. However, these face limitations such as poor scratch resistance, sensitivity to strong solvents, potential brittleness, heat deformation, and higher cost for premium types, with some formulations having odor due to VOC issues. They're popular for aesthetic appeal, durability in normal conditions, and biocompatibility in medical uses. Acrylic resins' limitations include poor heat and scratch resistance, brittleness, solvent sensitivity, potential yellowing, UV, and environmental concerns, making it prone to deformation and cracking, losing clarity and strength over time. These are difficult to recycle, especially impacting high-stress or outdoor uses despite its aesthetic appeal and versatility. Polyacetal, known as POM, resins are high-performance engineering thermoplastics prized for replacing metal parts due to their excellent balance of mechanical properties and easy machinability. Key advantages include high strength, low friction, and excellent dimensional stability, while primary limitations are poor UV resistance and difficulty in bonding. Without special UV stabilizer additives, polyacetal degrades quickly with prolonged sunlight exposure. It has low resistance to strong acids, e.g. sulfuric acid, and alkalis, limiting its use in these specific chemical environments. Their low surface energy and high chemical resistance make it very difficult to glue or bond effectively without special surface treatments, requiring mechanical joining methods instead. POM is flammable and burns easily without the addition of flame-retardant additives, which increases cost. It is more expensive than commodity plastics like polyethylene or polypropylene. Polyamide resins, commonly known as nylon, are valued engineering thermoplastics offering an excellent balance of strength, durability, and chemical resistance. Their primary limitations stem from moisture absorption and relatively high cost. Polyamide resins offer a strong combination of properties that make them an essential material in many industries. Despite their numerous advantages, polyamides have some drawbacks that must be managed for specific applications. Achieving precise dimensional control can be difficult due to shrinkage during molding and the effects of moisture absorption. Some polyamides, particularly in dental applications, have been noted to have issues with color stability, being prone to staining from substances like coffee. Silicone resins excel in heat, UV, water, and electrical resistance, offering biocompatibility, flexibility, and durability for aerospace, medical, and construction uses. These have good biocompatibility, being non-toxic, hypoallergenic, and compatible with human tissue, used in medical and food-grade products. Silicone resins have lower tensile, tear, and abrasion resistance than organic polymers. Generally more expensive than alternatives. These are more permeable to gases, like oxygen, than other rubbers. Some formulations need specific high temps or longer cure times. Technology Education and Mentoring Center stands committed to its aim of popularizing the field of fiber-reinforced composites.